This is now section 1.7, and we have reached the point that the stuff that everybody loves, and that is word problems. So this whole section is about word problems, starting with just a skill that we need for word problems, to be able to write mathematical expressions and equations for verbal phrases. And so we're going to be translating some things here with these three short examples. First of all, number one, you'll see all kinds of these things in your assignment, like all three of these. So number one, a number x decreased by 4 then doubled. So that's just translating it into an expression. X decreased by 4 means minus 4, and then doubled is take the whole thing and double it. So we have to do it in the order that it mentions in order to get the correct expression. The second one is a little different. It's setting up a scenario here with a trapezoid. The area of a trapezoid with a height and first base of x. Second base is twice the length of the first. All right, so starting with the height and first base of x. I have the trapezoid drawn here, and so I'll do this is the height. That's going to be x. One of the bases is x. That one looks to be about the same height. And then it says the other one, the other base here, is double. So that's twice the length of the first. And so I'd label it that way to start with. Now, the area of a trapezoid, we'll have to recall the basic formula for that, and it is 1/2 h times b1 plus b2. What we're going to do is fill in this formula based on the picture that we've drawn here. So height is going to be replaced with x. b1 and b2, we'll just plug those in as x and 2x. And then our job the rest of the way through is just to simplify this expression. So we can add the x's on the inside here. We get 3x. Now we'll combine, we'll multiply x's together, multiply numbers together, and the most simplified form of this expression is going to be 3/2 x squared. All right, that is case number 2. Case number 3 here is similar to one that you're going to see in your homework, but just a little different. It's actually going to be the opposite way. In your homework, they're going to talk about a circle inscribed in a square, and so you'll have to draw the picture a little bit differently. But here, a square inscribed in a circle looks like this. Right, the area of the square is a function of the radius of the circle. All right, so one thing is we need to know the radius. I'm going to make a center, and then I'm going to go out to one of the corners here. That's going to be our radius. Now, if we do this, there isn't a direct formula necessarily to get that square, but we can split this up, the square up into right triangles, specifically isosceles right triangles. So all of these will have a right angle in the middle. Now, that also means that all of these lengths are r. Now, if we want to find this square, what I would suggest is that we just focus on one triangle to start off with. We've got a base and a height. Both of them are r in this case. So let's do each triangle. Let's figure out the area of that first. And as you know, for a triangle, the area formula is 1/2 base times height. So we'll go 1/2, and then from one of these triangles, the base is r and the height is r. So we just have 1/2 r times r. And if we simplify that, that'd be r squared divided by 2. Now that we have the area of one of those triangles, if we want to get the entire square, we just need to multiply by 4. So the area of the square we'll take as 4 times r squared over 2. Okay, so then we do the 4 and the 2. That simplifies to a 2, and we have 2r squared, and that's going to be a simpler version of the area than what we would have had otherwise. So that's involving r. So in all these examples, we're just trying to get the simplest expression possible for the situation that is laid out in the problem.